Hello, Annav.
Hello, sir.
Everything good? I'm
Yes,
audible?
yes, sir.
All right. Any doubts from the last class?
No, sir.
All right. So in the last class, we studied about properties of union, right? Do you remember what is union?
Yes, union is for when two things are all the things that are in the sets, we write them in one set, removing all the common things.
Absolutely right. And these are few properties, right?
Yes,
A union B is equals to B union A. We can reverse the order, and this is called associative, right? If you take this
yes,
union, then you take union with the third element, that would be equals to this union and the third element, right? A
yes, sir.
union phi is A, right? This you can remember by this thing. If you have a small set and a larger set, all right, if you take union, then the union will always be either bigger or equal to the larger set, right? What does it mean? Right. Suppose we have a set A where 100 elements are there, all right, and a set B where 10 elements are there, all right. If I say A union B, then this will either be more than 100 elements or equal to 100 elements, right? It cannot be less than 100 elements. This is clear?
Yes, sir. Shall be equal
Because
to 100, right? Oh, no, no, I didn't know.
no, it
Yes,
can be true also, right? Because if I write A set as A, B, C, D till Z, and a B set where A, E, I, and O, U, all right. Now, if you take union, then we'll get set A as the answer, right? Because these are the common elements also. We don't write common element twice, right? So this will
yes,
be equals to A set. This is clear now, Arnav?
yes, sir. Yes, sir.
But if I write another thing here, suppose I write 1, 2, 3, 4 also. Now you have to write 1, 2, 3, 4 in this set also. So we'll have
Yes,
26 plus 4, 30 elements, right? So
yes, sir.
either A union B will be equals to the larger set or more than, right?
Okay, sir.
So this is clear. Now, what is the another thing? Intersection of sets. All right. Intersection of two sets A and B is the set of all elements which are common to both A and B. All right. What this means, if you have a set A 1, 2, 3 till 10, and a set B 4, 5, 6, and 7. All right. Then let's write more elements 4, 5, 6, 7, and 11, 12, and 13 also. Now, if I ask you A intersection B, all right, this is the symbol. You can write it here, and this is denoted by, all right, inverse U. So
Yes,
A
sir.
intersection B will be the common
4,
elements
5, 6,
between
7.
A and B. All right, common elements. What will be the common elements here? 4, 5,
4,
6,
5,
7.
6, 7.
Absolutely right. So this will be A intersection B. All right. So we can define A intersection B is the set of all X such that X belongs to A and X belongs to B. Right? X should belong to both of the set. All right.
Yes, sir.
Please note it down.
Done, sir.
Give you a question. A is 0, 2, 4, 6, 8, and 10. And B is multiple of 3. A natural number less than 50.
So
Alright?
you close the set after multiple of, or that is 3?
No, this is multiple of 3 and a natural number
Okay, sir.
less than 15. Alright? This
Yes, sir.
is all the, you can write it more clearly as this x, such that x is a multiple of 3 and a natural number less than 15. You have to tell me the answer. This A intersection B. What will be the answer to A intersection B?
So it'll be 6.
6. Is that all?
0 and 6, sir.
0. Is 0 a natural number?
Oh, no, not that, sure. Okay. It'll be only 6.
Yes. This is the right answer. The only element here is 6. Alright, this is clear enough.
Yes, sir.
Alright, you can write down this question. Then we'll do one more question on this. If A equals to 3, 5, 7, 9, 11, B equals to 7, 9, 11, and 13, and C equals to 11, 13, and 15, and D equals to 15 and 17. Then you have to write A intersection B, B intersection C, A intersection C intersection D, A intersection C, B intersection D, A intersection B union C. So 6. 7th is A intersection D.
Sir, can you raise the screen a little? Yes, sir.
All right.
Yes, sir.
All right. These are all the parts of this question you have to solve. I'll give you a few minutes.
So the first one is 7 and 11.
All right. A intersection B is 7, 9, 11. Absolutely right.
Then the second one is 11.
11 and 13.
Yes,
Right.
11 and 13. 11 and 13.
All right. And this one?
This one is null. Five. It's null set, empty set.
Null set. All right. This one?
So it's only 11.
All right.
This is null
Next
set.
one? B intersection D is null set. Okay. This one?
So that is 11.
Look again.
Okay, wait. 11 and 13. Yes.
11 and 13. Is that all?
Yes, sir.
Let's see. First, we can calculate B union C. So what will be B union C? Can you tell me?
Okay, so it'll be 7, 9, 11, and 13.
Absolutely right. So 7, 9, 11, and 13. No, not even 13, right? Because we are taking intersection. There is no 13 in A. So only 7, 9, 11,
Oh, yes, sir.
right? Because we take the common elements. All right.
Yes, sir.
Now seventh one.
The seventh one is 5.
Eighth one.
Eighth one is 11 and no, 11. 11
Check
and 13.
again.
A intersection B union D.
First, try to solve
It's
this one.
7, 9, and 11. 7 and 11.
Absolutely right. And this one.
Sir, it's 11 and 13.
Again, solve this, then take intersection.
Okay, sir. One. Sir, 7, 9, 11.
Right. Now last one.
7, 9, 11, and 15.
7, 9, 11. We have got 3, 2, 15, 17, 17 to 15. Right. 7, 9, 11, and 15. Right.
Yes, sir.
All right. So this is clear. You need to note down the answers, Arnav.
Yes, sir.
Do you want to note down the answers, or shall we move on?
Yes, sir, you can move on.
All right. Let's solve one more question on this. If A equals to 1, 2, 3, and 4, B equals to 3, 4, 5, and 6, C equals to 5, 6, 7, 8, and D equals to 7, 8, 9, and 10. Same type of question, A union B, but this time don't make any silly errors. A union C, B union C, A union B union C, A union B union D, B union C union D. All right, this is all you have to solve, all the parts. All right, don't make any mistakes now. All right, this is very easy question. You just have to be careful.
So the first one is 1, 2, 3, 4, 5, 6.
Right? A union B is 1, 2, 3, 4, 5, 6. Absolutely right.
The second one is 1, 2, 3, 4, 5, 6, 7, 8.
1, 2, 3, 4, 5, 6, 7, 8. Absolutely right.
The third one is 3, 4, 5, 6, 7, 8.
All right.
So this is from 1 to 8.
All right.
This is from 1 to 10.
And last one.
So from 3 to 10.
Absolutely right. All right. So very good. This is absolutely clear. This was the question of union, right?
Yes, sir.
I was thinking you will make the mistake of taking this as intersection, but
Yes, sir.
very good. All right. All right. So one last question on this topic, and this also you have to be careful. This is easy,
Yes, sir.
but be careful. All right. So if a equals to all x such that x is a natural number, b equals to all x is an even natural number, and c equals to x is an odd natural number, and d equals to x such that x is a prime number. All right, then you have to find out a intersection b, a intersection c, a intersection d, b intersection c, b intersection d, c intersection d. All right, this you have to solve. And now, are you writing down the questions or not?
Yes, sir, I'm writing.
All right, think about this very clearly. Take your time. Be careful.
Yes.
I need a perfect answer. All right.
Yes. So can I give the answer in the form of another set, like for the first one, A union B? Never mind. So never mind.
All right.
I can answer in the form of another set, right? Like for the first one, the answer will be set B.
Right. You can answer this in the sets.
Yes,
All right,
then the
this will be
second
set B.
C, set C.
Let's see. Let me also see the question. Natural number, even number, odd number. Yes, this will be set B. This will be set C. A intersection B will be
Set D.
set D. All right.
The next one is null set.
Set
Then that is 2, just 2.
just two. Prime
Yes, sir.
number and even natural number. That means two. Right.
Sir, and this is set C.
Odd number and prime number. So all odd numbers are prime numbers.
Yes, sir.
Sure about that?
Yes, sir. So because all
Nine.
odd numbers.
9 is an odd number.
Prime. Okay. So then it'll be set D without 2.
Right. Set D without 2.
Yes.
Right. So is there no even numbers in set D?
So what?
Is there any even number on set D?
So set B.
Set D, because you said the answer is D minus 2, right?
Yes, sir.
D minus
Only
this
2. Only 2 is the even number. No other even
right?
number.
Absolutely right. So this is clear. This is also clear.
Yes, sir.
All right. Now few properties of intersection. A intersection B is equals to B intersection A. This is very easy, commutative. A intersection B intersection C is equals to A intersection B intersection C. Associative. What will be A intersection phi?
Will be 5.
Phi. A intersection A.
So it'll be A.
And A intersection universal set.
So it'll be A.
A. Absolutely right. Now we can also do this. A union B intersection C. This is equals to A union B intersection A union C. All right, this is called distributive property. Right.
Okay, sir.
All right, this you can feel right. What I did here: A union B intersection A union C. All right.
Yes. Yes, sir.
Note it down.
Then, sir.
All right. Another kind of set is disjoint set. Right, two sets A and B will be disjoint sets if A intersection B is phi. All right, this is that easy. If intersection is phi, then they will be called disjoint sets. For
Yes.
example, 1, 2, and B is 5, 6. So A intersection B is 5. These are disjoint sets. All right.
Yes, sir.
All right. Note it down. We'll solve one question on this also.
Then, sir.
All right. Write it down. state whether each of the following statement is true or false.
Sir, what is the importance of disjoint sets?
See, before asking this, uh, before telling this answer, you can tell me about why we are studying about sets. What is the importance of sets itself, right?
I don't really know.
Yeah, exactly. See, uh, why sets, right? Because to in mathematics we like to categorize things, right? We like to
Yes,
talk about things. We like to categorize beautiful things and things that we see in the nature, right? All the numbers and different things. Now, whenever I tell you about prime numbers, right? What do you think about? You think about a number that is not divisible by any other number, only by one or itself, right?
yes, sir.
Is this not a set,
So it is.
right? We don't write it in this format, but this is a set, right? We categorized all the numbers who are not divisible by any other than itself or one as prime numbers, right?
Yes, sir.
So this categorization was always there in the society, right? A fruit that is red and have few seeds and tasty is called apple, right? If you see an apple, you like you say this is an apple. That is a category, right? So set is there. Now, what is the application in mathematics specifically? For an example, there is a chapter in your syllabus, probability, right?
Yes, sir.
In childhood also you have that chapter studied about that chapter.
Yes, yes.
So uh, in 11th you think about probability in a different way. From class 9th or 8th you have studied that if you have three red balls, five black balls, what is the probability of choosing a black ball? You say 5 by 11, like that. But in here in 11 you will look at probability in a different way, in sets format, right? If you have these kind of events where you have these outcomes, that one you can get, two you can get, three you can get, four you can get, six and seven and so on. All right. Now, if they ask you to choose one element of out of this, what will be the probability of choosing that element? In that way, you will learn about probability. All right. So in here
Yes,
also we use sets. Now coming to your question, what is the importance of disjoint sets? If you look at probability, if I tell you A and B have nothing in common, in probability we read that as what is the probability of A and B happening at the same time? Is it clear? Arnav, is this thing clear? In probability, if you see as intersection, we see this as what is the probability of A and B happening at the same time. Now connect this to sets. If you have a set A, this 1 to 6, and B were 10 to 11, 11 and 12. Now we have A intersection B 5, right? So if you throw a dice, there is no way that these two will occur together. Is it clear now?
yes, sir.
Now, so this is the importance of disjoint sets. If you can figure out that these two sets are disjoint, that means you can figure out all the things related to the intersection of these sets. All right, Anna?
Yes, sir.
I hope this was clear.
Yes, sir. Yes, sir.
All right. These are few examples, and many more are there in computer science. You can see like billions of examples. All right.
Yes.
Okay, let's move on. I was giving you a question, I think, right?
Yes, sir. On disjoint sets.
All right. State which of the following are true and false, and this remove this. Don't write this. Now, starting from first statement, I'm writing this below here. 2, 3, 4, and 5. 5 and 3 6 are disjoint sets. Second one is A, E, I, O, U and A, B, C, D are disjoint sets. Like these two questions, you have to say if these they true or false.
The first one is true.
All right.
No, sir, first one is false.
And why are you saying true?
Sorry. First one is false. 3 is common.
Right.
Sir, and second one is also false.
Right. Because A is also there. Right.
Yes, sir.
So both the statements are false. All right. This one, so it's very easy. Questions are there. In fact, whatever we have studied till now is very easy, right? And
Yes, sir.
there is nothing to be confused about if you remember these things, if you keep revising, right? Otherwise, you will face a lot of troubles. All right. Now, next topic is Venn diagram. Did you write that question? Previous one?
Yes, sir.
All right. Are you sure you wrote that?
So what?
Are you wrote that previous question?
Yes, sir.
All right. Venn diagram. So I told you about Venn diagram previously also, right? We draw
Yes, sir.
rectangles and circles. So why
Yes.
now again we are going to look at operations on sets diagrammatically. All right. So all those were operation of sets, union, intersection, and so on. Now, how to look at those things in diagrams? If I write union, how I can represent that? This is our universal set U. There is a set A, there is a set B. This is A, this is B. So union will be all of this area covered by A and B together. All right. All of those elements that are covered in this area, total area, is called A union B. This is A union B. All right. Because we take all the common elements or all the elements in a single set, that is union, right?
Yes, sir.
So this is the way to represent A union B. You have to put together all the area covered by A and B. All right.
Yes, sir.
You can note it down. Done.
Just a second, sir. Done, sir.
Right now, what is left? Intersection of sets. That is A intersection B. This you can represent. If this is A, this is B. Then only the common elements are there, right? And now only the common elements. That means we have
Yes.
to take the common area only. So this is the intersection of A and B.
Okay, sir.
All right, only the common area.
Done, sir.
Now one small operation is there also, that is called difference of sets. Sorry, difference of sets. All right, this is denoted by A minus B. All right, this is nothing but A minus A intersection B. All right, what does this mean? You don't need to know the definition also. What does this mean? If you have a set A, 1, 2, 3, 4, 5, and 6, and a set B, 4, 5, 6, 7, 8. So if I tell you to find A minus B, all right, this is called difference. So you have to remove all the common elements from A. All right, you are subtracting all the elements that are in B from A. All right, this 7 and 8 cause no problem because only the common elements are 4, 5, 6. Remove those from A, you will get 1, 2, and 3. This will be the answer. All right, is this clear enough?
Yes, sir.
So what does difference of sets mean? Only the elements that are only in A, right? Not in B. Absolutely. That will be the answer. So how to represent this in Venn diagram? This is A and this is B. So only the area which is of A individually. B should not have any participation in that. So in formula we write A minus A intersection B. That means this circle here is A and this part, middle part, is occupied by B also. So the only area here is this one. Am I clear here?
Yes, sir.
All right. So this is A minus B. You can note it down.
Done, sir.
All right. One more little thing is complement of set. What is complement of set? Denoted by A, C, or A dash. All right. This, if you see, this is called a complement. What is this? If you remove set A from universal set, you will get a complement. All right. What this means? Do you remember universal set? Do you remember universal set U?
Yes, sir.
So if you remove a set from universal set, whatever remains is a complement. Simply, which means if U is 1 to 100 and A is all the even numbers from 1 to 100, then A complement will be all the odd numbers from 1 to 100. Why so? Because if you remove A set from universal set, what is universal set? 1 to 100. If you remove all the even numbers, what will you be left with? Odd numbers. That will be complement. All right.
Yes, sir.
So we can say another way that A union A complement is always universal set. All right. If you put together A and A complement, that will give you universal set. All right. All of the elements will be there. Whatever is not in A will be in A complement. And diagrammatically in Venn diagram, how we can show this? If this is set A, this is U, this area is covered by A, remove this and whatever remains is A complement. So this, all of this, just not the circle, is A complement. All right, enough?
Yes, sir.
This is clear, right?
Yes, sir.
All right. Note it down. All right, give me 2 minutes. I'm coming back in 2 minutes. Till you know.
Sir, the class is up. So after this, can we end the class?
Why?
Sir, it's 1 hour class, right?
I think it's 1.5-hour class today. I also asked my team.
So they told me it's 1 hour class every day.
Do you have
Because,
another class right now?
yes, sir. There will be another class.
All right, give me a moment. All right, Arnav, just give me a second then.
Okay, sir.
All right, Arnav, we can end this class now. But you take all the other classes of 1.5 hour, right?
No, sir. All classes is 1 hour. That's
All
what I was
classes.
told. All classes end at 1 hour.
All right, no issues. Everything is clear about today's class, right?
Yes,
No
sir.
doubts from here.
No, sir.
All right then. You noted this down.
Just a second, sir.
All right.
Yes, sir.
All right. We can end this class now and see you in the next class. And are you completing the assignments that our team is sending you?
Yes, sir. I am doing those. And they're
Alright,
not
and
completed. I think I can complete it by the next class.
all right then. I hope to